Welcome to Cyberoam Online CCNSP Training Module 3. In this module, we'll be learning about the firewall. So let's have a look at the Cyberoam Layer 8 firewalling technology. Cyberoam adds a virtual layer which we call the Layer 8, and it's a patent pending technology. Now it has got an identity-based firewall, and that's the technology which Cyberoam gives you in terms of Layer 8 firewalling. So apart from the traditional 7 layers, there is a virtual layer wherein we stamp the identity, and that's what we call layer 8. So let's have a look at the access controls. Now the screenshot which we are seeing here is the default settings at the Cyberoam. So here it says that in the LAN you've got HTTP allowed and HTTPS allowed, which means under admin services. So it means that you can access Cyberoam on HTTP and HTTPS from LAN. You can access Cyberoam by default from WAN on HTTPS. Telnet and HTTP are plain text communication, and hence it's disabled by default. However, if you want, you can enable SSH from the WAN side since it's encrypted. So you can use appliance access to limit the administrative access to the following services. So all you have to do is you go to System, Administration, and Appliance Access. And here under Admin Services, you have controls on accessing Cyberoam, GUI via HTTP or HTTPS, or console via Telnet and SSH from any of the zones. So if you uncheck Telnet over here, let's say for example if you uncheck that, you won't be able to telnet to Cyberoam LAN IP. The same thing goes with authentication services for user login. So you can see here Windows or Linux client is allowed from LAN, however it's not allowed in DMZ. So if you have got any custom users or specific users in the DMZ, you'll have to enable Windows or Linux client for authentication from DMZ. The same thing goes with network services like DNS and ping. So by default, DNS is allowed and ping is allowed on LAN, but it's not allowed on WAN, and it's not even advisable to enable ping on the WAN. However, for VPN, you see it's not checked. So when you have got a running VPN tunnel and you want to ping Cyberoam, enable ping in VPN zone, or else you will not be able to ping via VPN. For web proxy and SSL VPN, by default, SSL VPN is enabled in all the zones and web proxy is enabled on LAN. So if you have got any DMZ users who are going to use Cyberoam as a proxy, you have to enable it on the DMZ zone as well. Let's have a look at the default configuration for access control. So when Cyberoam appliance is powered up for the first time, it will have a default access configuration as specified below. For the admin services, HTTPS will work on default TCP port 443, SSH will work on default port 22. For authentication services, it will work on UDP port 6060, and captive portal works on port number 8090, which is TCP. So these are authentication services are used by Layer 8 engine to authenticate and authorize user to apply Layer 8 controls, which is the identity-based firewalling technology which we innovated. Now the IP addresses assigned to each port on the appliance can be either static or dynamically obtained from DHCP server. So if you're talking about the WAN interface and you've got a dynamic IP address from your ISP, doesn't matter. You can set that interface to have a dynamic IP address and it'll automatically get the IP address from the respective DHCP server. The appliance itself can function as a DHCP or a DHCP v6 server. So if you want Cyberoam to lease out IPv4 or IPv6 addresses, Cyberoam can act as a DHCP server. The IP addresses can be edited and virtual interfaces can be added by adding aliases and VLANs. The advantage of using an alias is that a single interface can have multiple connections to a network. A very good example of using an alias would be, let's say you've got a pool of 5 public IP addresses in the same subnet from your ISP and you want to bind all the 5 public IP addresses on the WAN interface because you want to host different servers on different public IP addresses. That would be a very good example. That's when you go ahead and add alias to your WAN interface and you bind those 5 public IP addresses. In VLAN, the hosts communicate as if they're attached to the same broadcast domain, regardless of their physical connectivity. So Cyberoam can act as an inter-VLAN router and giving you more controls on the inter-VLAN routing. So you've got a layer 2 switch with multiple VLANs. You can use Cyberoam as a layer 3 inter-VLAN router. And apart from that, you can control traffic and apply security policies from one VLAN to another VLAN. And that's why it works in a much better manner than a traditional layer 3 router, which can do inter-VLAN routing. Because when you go with Cyberoam and use Cyberoam as an inter-VLAN router, and that's when you can apply security policies to that. So let's have a look at the labs. In the lab 6, we will do how to secure the appliance. So I'll RDP into my lab infrastructure, and let me log into the Cyberoam. Alright, now I'll go to system, and I'll go to administration, and I'll go to appliance access. So here securing the appliance is mainly referring to securing the appliance access from the WAN side. And you see by default only HTTPS is checked on the WAN. But I have enabled SSH. That's not the default settings. You'll only see like this as the default settings. That's the factory default settings of Cyberoam from the WAN side. Now how would you secure the appliance? You can enable HTTP as well from the WAN side, but that's not a secure way because that's plain text. So it's not advisable to enable Telnet as well. So better we'll go with the SSH for the console option and HTTPS for the GUI action. And I'll click on apply. I'll click on OK. And that's how my appliance access is secured from the WAN side. Now another thing which you need to remember is, see, the default setting says no ping allowed on the WAN. Now this is not advisable to enable ping until and unless you specifically need it on the WAN side, because there are a lot of ping sweep softwares which can identify that, okay, there is some firewall over there on that particular IP address. So better don't enable it, because that might create issues with your security of the appliance. So but if you still want to go ahead and enable ping, you can select on the ping option in the WAN side and click on apply. And now I'll be able to ping my appliance from the WAN side. So let me try and ping the WAN IP address. So I will, just for the sake of the demo, now you can see that ping is allowed on LAN. So I'm actually behind Cyberoam. So I will ping. That's my LAN IP. I can ping it. So let me just uncheck it. And before I uncheck it, let me start giving a continuous ping. Let me uncheck the ping option in the LAN. Click on OK. So now you see ping is disabled on the LAN side. Let me see what happened to my continuous ping. So it timed out. So that's how you can enable and disable ping. And I'll go ahead and enable it as well again, so that it doesn't create a problem for me. And let me see whether it comes back up or not. Yes, it came back up. Alright, so that brings us to the end of this lab. Let's proceed with the presentation. Alright, so let's have a look at the zone management. So Cyberoam default zones are LAN, DMZ, which is the demilitarized zone, WAN, VPN, and local. So these are the default zones provided by Cyberoam. Now the VPN zone is automatically created and given to you by default, so that when you configure VPN, you make use of this VPN zone to create the different rules from and to VPN. Now the local zone, it's probably a bit complicated at this point of time, so I need to spend some time here. Local zone comprises of the individual ports, the physical ports of the appliance. Now don't get confused with that. Remember, if you connect a switch to the LAN port, that all the computers connected to the switch itself is in LAN zone, but the physical port itself is in local zone. Why do I need a local zone? This zone has been given to you specifically to control access to a specific port in the appliance. So all the physical ports by default and only the port number, only that particular interface is in local zone. So any traffic which is destined for Cyberoam falls under local zone as well. So that's the use of local zone. So let's say, for example, you'd like to go home and access Cyberoam from the WAN interface and you'd like to restrict it to your home static IP address. That's when you create a firewall rule that WAN to local port B, which is the WAN port, and you restrict the access to that particular WAN port only from your home IP address. This will be more clear once we go to the next firewall tab option and we show you how to create rules, which when it will make more sense. But these are some of the examples of when should you use local zone. Now, Cyberoam offers you zone-based policies. Cyberoam, being a zone-based firewall, allows zone-based rules. For example, different policies for Wi-Fi zone, LAN zone, etc. This can be achieved from the firewall rule page, which is discussed in the later part of this module. Let's have a look at the rule management. So the first thing what I would like you guys to do is open up your Cyberoam and go to the firewall tab and then go to the rule tab, and you'll be seeing the same screen as I'm seeing in the screenshot in this particular slide. So here the first thing what I would like to tell you is there are rule IDs 1, 2, and 3, and there are 3 rules. I'm sure that at this point of time in your screen you are seeing rule ID 1 and 2 only, because these are the 2 default system created rules, and the DNS rule we have created it intentionally. The first thing what I would like to tell you before I move further in this slide is, why do I need a rule ID? I normally ask this question in my training and some people come up with answers, logical answers. Probably it's the order of rule creation, it's the way how the rules are number, it's a random number. No, the rule ID is given for you to identify a traffic is going via which rule. When I do the lab, I'll show it to you. When you browse or when you send any specific traffic from any specific computer, you see in the packet capture tool in Cyberoam which rule the packet is going through, and that's when it's very handy for troubleshooting these rule IDs. You need to know which rule it's taking through. So if you want to create a IPv4 rule or whether you want to create an IPv6 rule, you have to select it accordingly. This screenshot displays the IPv4 rule. Now, there are some settings to enable a rule, or if you want to disable a rule, you can see it over here, the on and off switch. Now these two, rule ID 1 and rule ID 2, are system created rules and they can't be disabled by default. However, you can change or modify the rules, but you can't disable these two system created rules. There's an option, the small toolbar icon at the right hand side of the page, and that's what you do to modify or change a rule. There's an insert button just beside the toolbar icon. So let's say if you like to create a rule at the top of the DNS rule, that's when you click on the insert button and you add a new rule, and that rule is automatically placed at the top of this rule. Now you might be thinking, why do I need an insert button and why do I need to put a rule at the top? I can put it anywhere in the rule page, doesn't matter. It does matter. The first thing I'd like to tell you is the rule processing in Cyberoam happens from top to bottom. So it's a top-down approach. The first rule is processed first from the top. If it doesn't match the criteria, then it goes to the next rule and goes to the next rule and hence forward. So remember, this is very important for your troubleshooting and configuration as well. The rule processing in Cyberoam is always from top to bottom. So if I take an example of this sample screenshot and you try to browse your traffic, the DNS traffic or first traffic will always go via the DNS rule. Then it will go through the second rule. If it doesn't match, it goes to the third rule. So that's how the rule processing is done. That's why we've given you another option to move a rule up and down. So in case you need to modify or move a rule up and down the particular rule page, you can do that. So you'd like to say create 5 or 6 rules and then you'd like to move the third rule at the top. because you want that rule to be processed first. You can click on this move icon out here and you can move, drag, and put the rule at the top. Another thing what I'd like to tell you, you need to give a close look at rule ID 1 and 2. There is a significant difference between these two rules. The rule ID 2 says any live user, which means this rule will be processed only if you are an authenticated user. Whereas the rule ID 1, it says, no, I don't need an identity, everything is allowed. See? Any host, except, or action is accept, and it's allowed. So as of now, if I try to browse, let's say google.com for the same rule base, which rule should I be taking? Yes, you guessed it right. I'll be going via rule ID 1. But let's say I authenticated myself and then I started browsing google.com. Then I'll be going via rule ID 2. But that's the major difference between this identity factor, and that's what we do. Let's have a broad look at the next slide. Yes. So this shows in broader detail what exactly the criteria is which you can modify in a particular rule. So this is the rule ID 1. Without authentication, you can apply the NAT, which is the default masquerade policy, which we cover in the later part of the slide. You can apply an application filter, web filter, IPS, instant messaging scanning. You can do AV and AS scanning, QoS policy, DHCP, route through gateway. If you have multiple gateways, you can also do load balancing, all tied in the single pane or in a single rule. You can also log the firewall traffic as well. However, this looks a bit changed in the rule ID 2, and the only parameter which is changed is the attached identity. So this is the change, attached identity. The rest of the parameters are the same. Now these things are disabled. You can change it over here, and the application filter policy is changed to user policy. Did you look that? The moment you are saying attach identity and you are saying any user, that's when the user's policy come into picture. Then you don't need to apply the security policies from the firewall rule, but you can always apply it on an individual user or on an individual user group. So these two are the default rules which are created automatically in Cyberoam, and you can modify them according to your own requirements. You can tweak these two rules. Now there are no IPv6 rules by default. User needs to create IPv6 as required by the network. So let's get to the labs, and let's do the lab 7 and 8, wherein we'll be creating a drop rule for our machine's IP address. And at the same time, after that, we'll create an accept rule for the machine's IP address. So I'll remote into my lab infrastructure. Now I've got my machine behind Cyberoam. I've got an IP address of 172.16.16.17, and I'll be dropping that particular machine's traffic for Cyberoam. Now when I want to block my machine's IP address for all the traffic through Cyberoam, there are two ways to do that. The first way is I can go to objects, I can go to host, and I can click on add, and I can say okay, machine IP, and then I can say I can put in my 172.16.16.17, and I can click on OK. And then I can go to firewall rule and create a rule from LAN to WAN, since I'm in the LAN of Cyberoam. Now I'll click on add, and I will say drop my PC. So the source zone would be LAN and the destination would be WAN. So I'll select it as WAN. Now here the source, I have to mention it as my machine IP. I'll unselect any and I'll select it to be my machine IP. Now the second way how you can do that, if you haven't gone to objects and added it, you can directly add it from here itself, the host IP address. It's the same screen which we got in the object tab as well. So either you can do it from here, or else you can create the object earlier and then select it. So I'll select the source as my machine IP, and I'll select the destination as any in the WAN. I would like to drop all my services, and I'll select the action as drop, and I'll click on OK. So my rule is at the top and it says it's drop. This is my machine IP for which I created the host object 172.16.16.16. Now let me go to command prompt and let me ping google.com and see all of my traffic is dropped. Now here is a good thing to notice is you might be thinking how if all the services are dropped, how is the DNS being resolved? Now if you take a look at the firewall rule set, I've got a DNS service at the top which is allowed. And after that I've got the drop rule. And hence DNS traffic is allowed, but rest everything is being dropped. So that brings us to the end of this lab. Let's continue with the next lab. Now lab 8. We'll have to create an accept firewall rule for your machine's IP address. So let us remote into the lab infrastructure. I can go ahead and create another rule to accept my machine's IP address, but the other side, like what I can do, I can go to the same firewall rule and all I have to do is select the action as accept on the same firewall rule and I'll apply the NAT. Now here we need to look that the source is still my machine IP, which is 172.16.16.17. So you need to select that object as a source and you can leave the destination as any. And I will scroll down and I will say, okay, I'll update the rule. And the moment I update the rule, let me try and ping Google and see. I started getting the ping. So alright, now I'll delete these two rules and let's proceed with the presentation. So let's have a look at the object management now. So objects are global building blocks for all modules or policies or rules of Cyberoam Layer 8 firewall. Cyberoam provides several standard objects and allows creating customized object definitions. Firewall rule for customized service definitions as well. So one of the objects which we created in our last lab was the host my PC. So I created a object called host based on an IP address for my laptop. So that can be a good example of an object. The same thing you can do for your customized service definitions as well. By default, Cyberoam gives you a lot of services, inbuilt services, so that you don't have to create a custom service. But if you want to create your own custom service, you can even do that. Let's say you'd like to create a service for RDP. You can go ahead and create a custom service for an RDP. So what you need to do, you need to go to objects, you need to go to services, and you need to click on add to open the create page. So you can just open up your Cyberoam and take a look at this page. And here in the screenshot, we're creating a service for RDP. The type is TCP or UDP, so you can select any protocol depending on the service or application, whatever it's using. It can be an IP, it can be ICMP, it can be ICMP v6. And then you select the source port. So for an RDP, the source port can be anything. It can be, that's why we put it under an asterisk, but the destination is always going to be 3389 until and unless you change that on your RDP server. So if you have changed that to a different port number apart from 3389 on your RDP server, you can select the appropriate port number over here, or else you can, if you're using the generic one, you can put in 3389. Now you can use this service in the firewall rule as well. So by default, IP host for all the ports on the appliance is automatically created. So you can see if you go to the objects page, by default, the objects for the ports are individually automatically created by default. So you don't have to create objects for your port number. So these objects will come into picture when there is a Cyberoam generated traffic from a particular port and you'd like to create a rule for that. That's when you use this system created objects. Or else it's the same way the second screenshot says, like we did in our last lab, we create an IP based object and you can make it an IPv6 object or an IPv4 object. You can name the object, you can select it on the basis of an IP address, it can be on a network subnet, on an IP range, or on a list of IP addresses as well. You can also alternately group multiple objects into a host group. You can create a host group and make a host part of that host group as well. Alternately, you can also create MAC host in Cyberoam. So in Cyberoam, MAC address or machine address is a decision parameter along with identity and IP address for the firewall policies. So if you want to create a MAC-based firewall rule to block a specific MAC address. Let's say, for example, if some guest of yours have brought in an iPad and you'd like to block the MAC address of that iPad so that it doesn't go online. In that case, all you need to do is first create a MAC-based object. You can either use a single MAC address or probably use a list of MAC address depending on your requirement. Put in the MAC address, and then your object is created over here in the MAC host, and you can use this particular MAC host in the firewall rule. Similarly, you can also create an FQDN host, which is very important. The best example of an FQDN host would be, let's say, here in the screenshot, we've blocked cyberoam.com. You can block it, allow it, do whatever you want. Most important example will be Google, because Google, when you ping Google or when you do an NS lookup for Google, it has got like 6 or 7 IP addresses depending from which country you are doing the NS lookup. Google has got a lot of IP addresses. So if someone comes to you and say that, how do you block Google via firewall rule? Oh yeah, Cyberoam can do that. You can create an FQDN host, www.google.com, or here in this case you've created it for cyberoam.com, put it to your host group, and then you can make use of that particular destination in the firewall rule. So you can say source LAN to WAN, source any destination, your FQDN host. It can be Google or it can be cyberoam.com, and we're dropping it. Don't worry, it's just for the lab we're dropping cyberoam.com, but yeah, you can drop Google or any other URLs, or not URLs, I'll say FQDN, which results to multiple IP addresses. Now, it doesn't make much sense when you have got a FQDN resolving to a single IP address. That's pretty generic. You can also block that particular FQDN on the basis of an IP address. But yes, if it resolves to multiple IP addresses like Google, it becomes very handy. But there's one thing which you need to remember. In order to have proper working of this rule, you have to be very careful that your Cyberoam DNS and your laptop or end user DNS should be same, because all we do is resolve the FQDN to the series of IP addresses for that particular FQDN. Now, if the DNS addresses doesn't match between laptop and Cyberoam, laptop is probably resolving to a different IP address. It can be a bit of a problem sometimes, so better maintain the same DNS on Cyberoam and on the laptop or end user computers. Same thing you can do for country host. Now you might be thinking, why would I need to allow or block a specific country-based traffic? That's why we've given you a lot of reports in the reporting section. There are a lot of country-based reports. So you get to see which country is attacked you, which country sent you more spam. And not only that, we've also given you a real-time generated traffic. Your organization is generating traffic to which countries and which countries are accessing your organization. There's an interactive traffic map in the report section as well. So when I come to that, I'll show you that. Once you see the different kinds of reports or country-based reports and traffic, then you have, okay, I don't do business with this country. So why do I need to allow why so many traffic of coming from that country? No, better I block that country. That's when a country-based host is very, very handy. You go to the country-based host, create an ad and select the country and put it in a host group and use the same in the firewall rule. So you can see that in the firewall rule, you're getting an option to select a country host or a group of country hosts and select it as a destination and then allow it or block it depending on whatever you require. Alright, so that brings us to the end of this particular session, and we are now left with the labs. So we'll do the labs 9 and 10. So lab 9 says create a schedule and apply it in the firewall rule, and lab 10 says create a firewall rule to allow DNS traffic. So let's just do the RDP and let's get started with the labs. So let me remote into my lab infrastructure. Now the first thing what you have to do is create a schedule and then apply it on a firewall rule. What exactly it's gonna do is, if I apply a schedule on a firewall rule, the firewall rule will be active during that particular schedule. So let's first create the schedule. So I'll go to objects and then I'll go to schedule. Now here you can see they've got some default schedules here, like all time on Sunday, all time on weekdays, work hours, 5 day a week or 6 day a week. But let me say I'm not happy with any of the schedule. I would like to create my own custom schedule. So I'll click on add to add a new schedule, and I will name it as custom schedule. And here I'll go ahead with recurring, and I'll say okay, I will select it from Sunday to Monday. Okay, let's say I'll choose Friday, and I'll give a time lapse of 1 to 2 during lunch hours on Friday, wherein I'll be applying it on a rule. So I've selected the start time of a recurring schedule on Friday 13, which means 1 p.m. and I will end it at 14 so that they've got 1 hour lunch break. And let's say I'll have to create a custom firewall rule where I would like to give them access only during lunch hours. So I'll go ahead and click on OK on the custom schedule. Alright, so I've got my custom schedule. It says recurring and it's valid from on Friday, every Friday, lunch hours during 1 to 2 o'clock in the afternoon. Now I'll go to firewall rule. And here I can add a new firewall rule. In real world scenarios, ideally we should be allowing or creating a real firewall rule where you have to apply the schedule. Alright, so I've created the schedule. Now I'll add a firewall rule and I'll say, let's say, allow Google, just for an example. Now this is just for demo purposes. I'm just trying to show you the concept. So the source zone will be LAN, destination will be WAN. Now source host, you can keep it as any, and then here I'll apply the schedule. I will select custom schedule. Now if I'll leave it like that, I'm actually trying to allow Google, so I can probably go ahead and add an IP address of 8.8.8.8 just for the demonstration purposes. So I'll do that as well. I'll click on OK, and I've applied the custom schedule here. Custom schedule, accept it and add it, and I'll click on OK. Now the moment I click on OK, you get to see a small icon beside the enable rule. This is for that particular schedule. You can see enable or schedule deactive. So this is gonna be activated only during Friday 1 to 2 o'clock in the afternoon. So this is how you apply schedule to an individual firewall rule. However, you can apply schedule to different modules in the Cyberoam, which we'll be doing in the later part of the presentation in other modules. So that brings us to the end of this particular lab. Let's go ahead with the next lab. So the next lab is lab 10, where we'll be creating a firewall rule to allow DNS traffic. So let me remote into my lab infrastructure. And first I'll delete this rule since I don't want any junk out here. And now I'll be creating a rule to allow DNS traffic. So I'll click on add, and I will name the rule as DNS, and then I will select the source as LAN, destination as WAN. I'll leave the source host as any, destination as any. And for the service, I will search it for DNS. Remember, it's a very handy tool, search option. And don't forget to select the service as DNS. So you have to select the service as DNS. I'll accept it, and I'll NAT it, and I'll click on OK. So now I've got a DNS rule at the top with the service DNS allowed for any host and any destination. So that brings us to the end of this particular lab. Let's proceed with the presentation. We're back to the presentation. So we'll do NATing, inbound and outbound NATing. Now first we'll do outbound NAT, which is source NATing. Now Cyberoam has a predefined NAT policy called masquerade, which NATs the outgoing traffic with the outgoing port's IP address. So it already has a default NAT policy. Now before I go further in the presentation, I would like to draw and explain the concept of outbound and inbound NATing. So what I'll do is I will go to my whiteboard and let's draw a particular figure. Let's say I've got Cyberoam over here. This is connected to my internet, and the public IP address I have is 1.1.1.1, and then you've got a switch, and then you have got your computers connected here. So let's assume that it's probably your 10.10.10.10. So 10.10.10.20, or I will say it's 10.10.10.0/24 subnet. And this is the IP address of Cyberoam. Let's say 10.10.10.1. So when these computers go online like this to the internet, how will they go? They all have an IP address in the private subnet, which is 10.10.10.10 or 10.10.10.20. So they're all having private IP addresses. They can't go online because it's not a publicly routable subnet. However, your ISP has given you a public IP address, which is 1.1.1.1. So this is public IP. So what we do in NAT, or the concept of NAT goes like, you've got so many computers around. When they go online via Cyberoam, they will go out like this with the IP address of 1.1.1.1. Let's say somewhere you're accessing google.com. So google.com, see, the request is coming from 1.1.1.1 and not 10.10.10.20 or 10.10.10.10. So this is called the masquerading NAT policy. In most of the products, you have to create a NAT policy saying that, okay, 10.10.10.0 subnet, translate it to 1.1.1.1, and it maintains the stateful connection table, mapping each and every private IP with the public IP address for outbound connections. So that's for outbound NATing, which is called masquerading, and Cyberoam helps you to give a default masquerading policy. You don't need to create anything by default. There is already a default policy. You don't have to create a NAT policy, an external NAT policy. All right, now the scenario changes a bit. I'll show you another example. Now let's assume that I've got Cyberoam here, and I've got my ISP, and I've got my switch here. I've got my computers here, and let's say this computer is 10.10.10.10. This is 10.10.10.20. Let's say I've got a web server over here. So let's assume this as a web server, a very simple and small network. So it's not that tough network. So let's assume this is a web server over here. And this time my company has got a pool of public IP addresses, so 1.1.1.1 to, let's say, 1.1.1.1.5. So I've assigned 1.1.1.1 to the WAN port. However, I want the web server, when it goes out, it should go out via an external IP address of 1.1.1.5, because my website, let's say abc.com, resolves to 1.1.1.5. So I want my web server to go out with 1.1.1.5. That's what I want. So I have to create another outbound NAT policy saying if source is 10.10.10.10, map it to 1.1.1.5. So when this goes out like this, and it goes out to some other website or some other network, that network sees the request is coming from 1.1.1.5, and that's called one-to-one outbound NATing or outbound NAT. So that's the source NATing, when you're translating the source to a specific IP address instead of doing the default masquerade. For rest of the computers around here in 10.10.10.0 subnet, they will be, when they go out to Google, let's say, so they will be going out, Google will see the requests are coming from 1.1.1.1. But when this web server probably goes to Google or any other website, Google or any other website will see the request is coming from 1.1.1.5. So that's the translation for outbound NATing. Okay. So what we have done in Cyberoam is we have given you a default masquerading NAT policy, which we call the masquerading NAT policy. So as you can see in the presentation, Cyberoam allows creating a NAT policy which can be bound to a firewall rule. So you remember the web server I'm NATing it to a custom or IP address from a pool of public IP from the ISP, that scenario. That's where you'll create the NAT policy and you come down to the firewall rule and say LAN to WAN. Source will be your private IP address. On this private IP address of your web server destination, any service, you can select it to be web, and you can apply the NAT policy, mail server NAT policy. However, for the rest of the computers in the network, they can use the default masquerading. So that's how the outbound NAT policy works. So let's have a look at the inbound NAT. I'll prefer to go back to the same diagram, and I'll draw another diagram for you. I'll delete this off, and let's take the same scenario. So again, a small company, I've got an internet connected over here. Let's assume I've got the public IP 1111, and I've got the web server here and other computers here. So I'll say 10.10.10.10, which is the web server. Alright, and this could be 10.10.10.20, and this could be 10.10.10.30. My website, which is hosted on a private IP address of 10.10.10.10, is resolving to 1111. So whenever anybody from somewhere sitting out here access, let's say, abc.com, which resolves to 1.1.1.1. So the request comes like this. Now you need to have a separate inbound NAT policy saying if any request comes for abc.com on port number 80, translate it to 10.10.10.10 and forward it to 10.10.10.10 because that's my web server, and that's called inbound NATing. The same thing can happen. You might have the WAN IP address as 1111, but however, you might want to access it on 1.1.1.5. And then the request comes to 1115, and Cyberoam, seeing the NAT policy table, will translate it to 10.10.10.10. So depending on what kind of scenario you're having in your network, whether you're having an external IP address or not, you need to take care of the NAT policy and create it accordingly. Now, there is another kind of NAT policy which we call it as reflexive. When you create the inbound NAT policy, let's say with 1115, of course you want that when this web server goes out to the internet, this one should go out like this. So whenever it goes out to Google or any other premises, that premises should see the request coming from 1115. Suddenly, there is a tight integration between the inbound NAT policy and outbound NAT policy in Cyberoam, and you don't need to manually create this outbound NAT policy or inbound NAT policy. We can do all of that via virtual host, which I'm going to show you next in the presentation. So virtual host. So you're required to make internal resources available on the internet, as I showed it to you via the diagram, and it mapped services of a public IP address to services of a host in a private network. So a very good example would be a web server configured in LAN zone with an IP address of 1111 from internet users and accessing abc.com, which is resolving to 10.103.4.213. The same thing, the same way I showed it to you in diagram. Users are requesting on a public IP address, but the website is resolving to a certain public IP address, and then you want Cyberoam to map it or translate it to a private IP address. So Cyberoam will automatically respond to the ARP request received on the WAN zone for the external IP address of the virtual host. And the default LAN to WAN, any host to any host firewall rule will allow the traffic to flow between the virtual host and the network. And Cyberoam also allows inbound load balancing and failover. So let's have a look at the virtual host configuration. So all you need to do, you need to open up your Cyberoam and go to firewall and go to virtual host and click on add. Now here are certain fields which you get. You have to put in a name, so I put in my web server, put in a description if you want, which IP family is the IP address of the web server belong to, IPv4, IPv6. Then you select the external IP address. Now this is where you need to be a bit careful whether you want to map your WAN IP address or the WAN interface IP address, or you want to select a public IP from your ISP's pool. So be very careful while you select this in case your website is resolving or probably you're hosting an RDP or FTP to an external IP address which belongs from the pool. Select that over here. Mapped IP will be the private IP address of your web server or RDP server, whatever server you're hosting. And you have to be very careful of the zone where exactly the server is located physically with respect to Cyberoam. Now this is the port forwarding, which is very important. You have to select the protocol, TCP or UDP for website, it should be 80. And you've got an external port and a mapped port. Now the external port can be 80, or we can also do a port translation to an 8080. So if you're hosting the website on 8080, so the users will type in abc.com:8080, but internally it's running on 80. So you can even do that, external port and internal mapped port as well. Or else you can just go, if you're not doing any kind of port translation for security, you can put it 80 over here and put it 80 over here as well. So depending on what kind of requirement you have. But yes, be very careful, enable port forwarding and select the appropriate port number, or else all the series of the ports will be open for that server from WAN to LAN. So be very careful and enable port forwarding for the particular service you're opening up wide open to the internet. Be very careful of the port forwarding settings. Now the moment you enable port forwarding in the advanced settings, you get another option, which is load balancing. And let's say you've got a server farm of 5 servers, 5 mirrored copy of servers running in cluster, and you want Cyberoam to load balance the inbound request to multiple servers because you're running a server farm with a cluster. So maybe you're having 5 servers and you want the request to be load balanced among the 5 servers. So you've got some different methods of algorithms, you can say, different methods of load balancing, which we'll cover in the next slide. And you've also got health check. So if one server fails, how does Cyberoam know that the server has failed and I shouldn't be forwarding the request to that particular server? So you can either do it on a TCP probe or you can do it on ICMP probe. Better to go with TCP because in case you go with ICMP probe and you've got some kind of Windows firewall in your server or any software antivirus or anything which blocks ping, you shouldn't be getting the response. The Cyberoam shouldn't be getting the response. As a result, Cyberoam will say, okay, this server is dead for me. I'll route it to the next server. So depending, if you're enabling ICMP, ensure that your server is responding to pings. If you're enabling TCP, you can put in a port number of the TCP on which you want to do the health check, and you can put an interval and timeout. After the timeout, and after 3 retries and 2 timeouts, Cyberoam will declare that particular server as dead and will automatically route the next request to the next other servers available. So what are the algorithms that we have or that you support? We've got round robin, first alive, random, and sticky IP. So let's have a detailed look at the different algorithms which you have. The first one is round robin. In round robin, the request will be served in a sequential order where first request will go to first server and then next and so on. It will not consider any other parameter. It's completely sequence, and it's just first request will go to first and next and next and next. That's how it works. The other algorithm is first alive. In this kind of algorithm, all requests will be served by the first internal server. The request will only go to the next server if previous one is dead, and so on. So this is not an equal load balancing. Remember, all of your requests will come down to the first live server, and your requests, any inbound request, will only go to the next server if the first server is declared dead by Cyberoam. The third algorithm is the random, wherein the request will be served in a random order, or rather we can say uniform random method, where all requests will be distributed evenly. So it's same like round robin, but the requests are distributed evenly. So it's an equal distribution of load among all the servers. And the last one is the sticky IP, wherein it maps a single source IP to a destination server. Any request from the same source IP will always go to the same server. So if I'm probably sitting in US and accessing a website which is hosted probably in our data center somewhere in London, I'm in my home in US and I'm accessing the server. As long as my home IP doesn't change, I'll always be hitting a specific server. let's say I went to UK or Australia, and from there I'm accessing the same website. So this time my public IP address changed, as a result of which the sticky IP algorithm will route me to a different server, because it always maps a source IP to a destination server. So these are the four algorithms which we provide for load balancing. Now you have to create a firewall rule to include the virtual host, because once you create a virtual host, your netting is taken care of, and the next process is to create a firewall rule to allow from WAN to LAN. So you have to create firewall rules to allow the external host from the internet to access a virtual host that maps to the internal servers. Now you must add the virtual host to a firewall policy to actually implement the mapping configured in the virtual host. That is, you have to create the firewall rule that allows or denies inbound traffic to virtual host. Don't be confused. Remember, virtual host is for inbound NATing. But we offer some additional features in virtual host. We also allow you to automatically create inbound and outbound mapping via this virtual host, which will show it to you in the labs. But then, if you're only relying on a virtual host and you're not creating the rule, the NAT policy is there, but there is no rule which is going to allow the request. So your request will be dropped and ultimately not be able to access the server from outside. So here you have to create a firewall rule, and we say from WAN to LAN, destination source can be any, and the destination is the virtual host which you created. And this virtual host takes care of the NAT policy. So I don't have to apply NAT anymore here. I'll just accept it and select the appropriate service. Now if you have done port forwarding on your virtual host, this service is automatically selected based on your port forwarding. You don't have to manually create a service for that. This service is automatically created. That's the beauty of Cyberoam. Everything is automated. And then you can apply some scanning or security policies if you want. You want to enable IPS if you want. You have to have antivirus scanning. If it's a web server, you can enable all of the security policies and you're done. Now there is another rule which is created while you create a virtual host, which is called the loopback rule. Now as I was explaining it to you earlier, I'll draw a small diagram and I'll do a quick demo of that. So you've got internet over here, you've got 1.1.1.1, and you've got your switch here, and you've got your probably web server here. So I'll just write it in a short manner, web, and probably you've got your other computers here. Now it is abc.com, let's say, for instance. Pardon me for my handwriting. That's alright. So abc.com resolves to 1.1.1.1. I'm here, I'm accessing abc.com. Alright. I'm accessing abc.com. It resolves to 1.1.1. Cyberoam does an inbound translation and forwards it over here. What happens when I'm the same user is inside the network? I don't know what's the private IP address of the web server. I'll still access abc.com. So the request goes out and sees, okay, it resolves to 1.1.1 and comes back like this. So it's actually going out and coming back, and that's how it's looping. So if the loopback rule is not created, any users, internal users sitting inside the network can't access the server which is resolving to the public IP address. And that's when you need a loopback firewall rule. So once the virtual host is created successfully, Cyberoam automatically creates a loopback firewall rule for the zone of the mapped IP address. Now do you see the word automatically? We make your lives easier. You don't have to go ahead and manually create a loopback rule. We created, most of the rules are created automatically. A loopback firewall rule is created for the service specified in a virtual host. If port forwarding is not enabled in virtual host, then firewall rule with all services is created. So you have to be a bit careful. You have to enable port forwarding. Otherwise, firewall rule with all services is created and all the ports in the server is wide open to your internal users and to your external users. Very careful of the port forwarding. Loopback rules allow internal users to access the internal resources using its public IP or external IP or an FQDN. So this is how it looks like. It's automatically created. So you can see the source, destination, and the service, and the action is accept by default. And it's a LAN to LAN rule if your server is on the LAN. So it's automatically created. The other rule is reflexive firewall rule. You remember in my last diagram I was talking about reflexive, wherein the server needs to go outside with the same external mapped IP address from the pool, not the normal default masquerade policy. So that's when you need to create a reflexive firewall rule. So in general scenario, when any traffic is initiated from DMZ to WAN, there's a need for the reflexive rule. And you don't want it to be routed with the masquerade NAT policy. You don't want that. You want to go it via specific outbound NAT policy for which the inbound NAT policy also exists. So for an example, in case of an email server, the private IP address of the email server is mapped with the public IP address on the internet. When an email is received, an inbound, the virtual host rule for inbound works. But when an email is sent, there is a requirement to create a reflexive rule. By default, Cyberoam prompts for this rule while creating the virtual host. Again, as I was telling you, it automatically does it for you if you want to enable that, and you get an option while you create the virtual host. So you don't have to manually create it later. You automatically get the option while you create the virtual host. This is how it looks like when you, after you're done, you click on OK on the virtual host configuration. You get this screen where you see you want to apply the scanning or you want to create a reflexive rule, yes or no. If you select yes, automatically the reflexive rule is created. And it's always advisable after you create the virtual host and click on the OK button, this is the screen you get. So enable the add firewall rules. There are people who don't enable it here and later on they forget to add the rule. And yeah, if you don't do it automatically from here, you'll have to probably create two rules, one for inbound, and then if you want the reflexive rule, you have to create it separately. So be careful, and it makes your life easier as well. So just enable it on the same screen while you create the virtual host. Now we also do inbound load balancing with virtual host and DNS. Let's take an example. Let's say a web server is published over two WAN links. So your company has got two WAN links, which is hosted on port B with an IP address of 10.206.1.12, and the other internet link is on port C with this IP address. Now, for the example's sake, just we are assuming that these are public IP addresses. Now the website NS record should be Cyberoam IP address 10.206.1.12, which is on port B, and 10.10.1.2, which is on port C. So what do? So you create the virtual host one with 10.206.1.12 as you see in the screenshot, and the other one with the other IP address 10.10.1.2. So you have created your two virtual hosts. What do you do next? You create a DNS host entry for server from network. So you have to go to the network setting, go to DNS, and go to DNS host entry. You name it as a host entry as web server if you're hosting a web server. Select the two ports, the interfaces, time to live, and ensure that you publish it on WAN. And you can also add a reverse DNS lookup as well if you want. If you're not hosting it on the interface IP addresses, but if you're hosting it on, let's say, from the pool, select it from the pool of IP addresses and then select the IP address over there. Now, upon failure of any WAN link, let's say port B internet failed, still your website is up and running automatically. Cyberoam will do the failover to the next IP address because you're hosting your website on two IP addresses, and Cyberoam gives you automatic failover for that with this particular configuration. And when both links are functional, like you see it here, both the links are up and running, Cyberoam will automatically do load balancing for your web server. So if you're accessing, like if you're hosting abc.com, so automatically some request will come in to port B and some request will go to port C, depending on if both the links are up at the same time. Alright, so that brings us to the labs, and in this is lab 11, and in this lab we'll create a virtual host to publish an RDP server residing in the LAN. So let's have a look at the lab and let's go with the lab. Alright, so let's get to the lab. We'll be doing lab 11 now, wherein we'll be creating a virtual host to publish an RDP server residing in the LAN. And you can do it using both IPv4 and IPv6. So let me remote into my lab infrastructure. And in order to create a virtual host, all I have to do is I'll have to go to Firewall, and then I'll have to go to Virtual Host, and I'll have to click on Add. And I'll name it as RDP. Now in the IP family, you can select either IPv4 or IPv6. In case you're hosting it on IPv6, your ISP is in IPv6 as well, you can select it to be IPv6. Now here, for the sake of demonstration, I'll choose it to be IPv4. I'll select the external IP. Now in this lab demonstration, I'll go ahead with the WAN IP address since I'm going to publish this on the WAN IP. However, you might have in some real world scenarios a pool of IP addresses wherein you can go ahead and select the IP address and add the public IP address from your pool. But here I'm not doing that. I'm just going with the WAN IP address. So this is the external IP, which is my WAN IP, and the mapped IP will be my private IP address of the server on which I'm hosting RDP. In this case, I've got a machine IP which is 172.16.16.17, which I created in one of my earlier labs. So I'll select that, and I've opened RDP on this machine. And this machine resides on the physical zone LAN. So this is very important. In case you're hosting some of your servers in DMZ, you have to select the physical zone as DMZ. But for the sake of demonstration here, my machine is in LAN, so I've selected it as LAN. Now I have to enable port forwarding. So I'll enable port forwarding, and RDP I'm hosting it on 3389. So I'll select the external port as 3389 and the map port as 3389. Now in certain scenarios where you might be hosting a web server or probably some other servers on a custom port number, then here you can do the port translation as well. Maybe you want to say that you're hosting RDP to the external world on 3390, but in reality you are actually hosting it on 3389. So that's one of the good example when you like to do port translation. But here I'm not doing any port translation, I'm just having the same external port. So if I want to go ahead and RDP to this my machine IP, I will do it on 3389. Now I'll click on OK over here. And once I click on OK, I get to add the firewall rule for virtual host. So this is a very handy tool, and it's an automated feature. You don't have to manually go ahead and create a rule. Now if you want to create a reflexive rule, you can go ahead and do that as well here, which means when this particular machine will go out to the internet, it'll be going out through the same public IP. Now that's normally not required for your WAN IP address. In case you are hosting it on a pool of IP addresses, you might have a requirement to create a reflexive rule. So I'm not selecting that, I'm setting it to no, and I'll click on add rule. So the moment I click on add rule, let's have a look at the firewall rule base. So say I've got a WAN to LAN rule for service as RDP. The service is automatically created. The destination is RDP. And apart from that, I also have got a loopback rule for accessing it from internally on the external IP address. So this loopback rule is also automatically created. Now if I want to go ahead and do an RDP from external world, I'll go ahead and do an MSTSC on one of my PCs, and I'll do it on the public IP address of 10.206.1.113. And this is the public IP address on which I'm hosting my virtual host for RDP. So I'll go ahead and do an RDP on 10.206.1.113, and that will be automatically mapped to the private IP address of the machine. So I'm not doing the RDP demonstration here, but yeah, you can do it for your own sake while you're doing the lab. But that's how I'm just trying to show the concept. This is how it works. So that brings us to the end of this particular lab. Let's continue with the presentation. Alright, so we'll do routing now. Static routing. So Cyberoam supports static routing. So what is static routing? I'm sure you already know what is static routing, but just to revise it. When you want to route traffic destined for a specific network or host via a different next hop instead of a default route, that's when you add a static route. Now, a static route causes packets to be forwarded to a different next hop other than the configured default gateway. Now, a very good example of a static routing is in this slide. I've got a Cyberoam over here with an IP address of 192.168.4.2, and I've got a L3 switch with different VLANs, VLAN 100, VLAN 101, and VLAN 102. But this is a bit different scenario. The L3 switch is doing inter-VLAN routing, and the L3 switch IP address is 192.168.4.1. So if Cyberoam wants to reach any one of the VLANs, let's say Cyberoam wants to reach VLAN 100, don't you think you need a static route? So you need a static route saying that, okay, if the packet wants to be reached, you need to add a route in the Cyberoam. If destination is 192.168.1.0 network, route it via this IP address. And that's how you add a static route in Cyberoam, which is in the next screen. So see, VLAN 100 static route. You've got 192.168.1.0 routed via 192.168.4.1. Same thing you do with VLAN 101. 192.168.2.0, you route it via 192.168.4.1. And you can add the static routes via the GUI itself. But I'd like to tell you one thing over here. Do you notice some limitations over here? In a static route, you only have control on the destination and on the gateway and on the interface and on the metric, of course. Is there anything else do you have control on? You don't have it. Okay, we'll talk about that in some of the later slides as well. Now, Cyberoam also supports dynamic routing. Cyberoam supports dynamic routing configuration from the GUI itself, and you can also configure it on the CLI as well, but it's easier on the GUI. So people who are pretty much handy with the GUI can go ahead and configure it in GUI. If you're pretty much familiar with the CLI, you can go ahead and configure in the CLI as well. So if you want to configure it in the GUI, you need to go to Network, Dynamic Route, and then you need to select which protocol you'd like to configure it. Now, we're not doing in-depth dynamic routing in this CCNSP course because in-depth dynamic routing is covered in CCNSE. So let's have a look at policy-based routing. Remember, in my last to last slide, I told you in static routing, you have just control on the destination, on the gateway, and on the interface, nothing else. So static routing method is limited to forwarding based on destination address only. And policy-based routing extends static routes, which provide more flexible traffic handling capabilities. It allows for matching based upon source address, service or application, and gateway weight for load balancing. So isn't that amazing? You are actually doing a static route, but an extended version of static route, which is giving you more granular control on the routing. So it offers granular control for forwarding packets based on a number of user-defined variables like destination, source, application, or a combination of all of the above. So how do you configure policy-based routing? You configure it from the firewall rule wherein you have control on the source, you have control on the destination, you have control on the service, and you select route through gateway, which gateway would you like to route it through. And you also have the option to select a backup gateway as well in case you're having multiple ISPs or multiple gateways. You can select a backup gateway as well. So if the main gateway is down, traffic will be automatically routed to the second gateway. So this is an extended version of static routing. So that brings us to the end of this module. So the next module which we'll be doing is the user authentication module. So thank you for attending the presentation.